Hi everyone. This video is about VISVAP and how to use VISVAP to code or to use a fixed time control plan, a signal plan in different time periods. When you don't have VISSIG module in your license, you cannot set up a different control plan, a fixed control plan in different time periods. So basically, let's say in the first hour you want to model one fixed time, and then in the second hour you want to model a different signal plan. So VISVAP can come handy in these cases, and there is a very simple way to do it, and I'm going to show you how. So what I have here is a simple intersection, a simple signal as intersection, and I have only 3 signals. So signal group 1 are these two and these. So these guys go 1. Then this is 3 and these are number 2. So first these run together, then these run together, then this runs, and then the cycle starts again. What I have is I have time intervals set up as constants. So let me go back to the VSWAP settings. So I have the PUA file on the left and I have the VSWAP on the right. So I think I just start quickly with the PUA file. So in the PUA file, I have these 3 signal groups set up, A, B, C, 1, 2, 3. This section is about the stages. So I say the stage 1 is when A is green and B, C is red. Stage 2 when B is green and in the same stage A and C are red. Stage 3 green and B and A are red. Then interstages. So as you know, I usually don't like to use intergreen matrices and to check for minimum green to happen because it just makes the logic more complicated, I think. It can make sense sometimes to use it that way if you have a complex control, but I like to just keep it simple, especially for these videos. And once you learn how to use these, then you can always just, go to the next level. So it is important that in these settings, in these interstages, I consider the intergreen and the minimum green. So as you can see here, this 6 means that 1A is red, B waits 6 seconds until it goes to green or until it becomes green. So this interstage is from stage 1 to stage 2 and the length is 12. This is very important. So as you can see, it waits 6 seconds for the intergreen between the change. So from A to B there is a 6 second. So that is our intergreen. And that extra 6 seconds after B is green is the minimum green time. So this way, while I am in the inter stage, basically I'm done with the intergreen and also with the minimum green. So I do not need to check for that in my VISVAP code. I just use very simply interstages. And I have an interstage description here for 1 to 2, then from stage 2 to stage 3, and from stage 3 back to stage 1. And it's very simple, just 6 seconds for all. In VSWAP, I try to use constants, so I don't need to change anything in the code. I just basically use a constant in the code, and I just change the number here. It makes it very simple to just see through and not to go into details and not to miss certain updates. So the way it works, or the kind of logic I try to develop, is something that you can copy paste. I use 3 stages in my fixed time, and I have 3 periods as well. So I have a period from 0 to 300, I have a period of 2 that is from 300 to 600, and one from 600 to 900. 300, 600, 900. These are in seconds, and the variable name I use, or the name of the constant, sorry, is period 1 end, period 2 end, period 3 end. You can change anything you want here. So it's just to make it easy to understand. And I also have, I store the green time in these variables or constants in this case. So for each period, for each stage, I have a time. It is very important that these green times are the actual stage time. So in this case, it shows 10 seconds, but we know that the interstage already has the minimum green, so it will be 10 plus the minimum green, so it's gonna be 16. So you need to take 6 away from this one. If you want your stage to run for 16 seconds, you need to put 10 here, because here I already have that 6 seconds. So 12 minus 6, that's 6. So, and 10 plus 6 is 16. The same goes here. So instead of 15, it will be 21, and so on. So here you just need to make sure that you set the stage time that is not inclusive of your minimum green. Okay. So the VISVAP logic, or the flowchart, is built up from 4 sections. The first section is the initialization. Here, I just basically start a timer called simulation time. It's just very simple. I say here that init equal 1. If init equals 1, then I come in here and I change that variable to 1 and start the simulation time at 0. This init can be anything, so it can be init GT, and you can use the same thing here if you want. So it's just a random name you choose. It just makes sure, so when there is a new variable in VISVAP, the 0 is 0. Sorry, the starting value is 0. So when it starts running first, that variable has the value of 0, so it will be true, but it will not be true ever again. So this only happens once during your model run. Then there are 3 blocks. Block 1, 2, 3. The reason I did it this way, because if you have multiple time periods, you can just copy paste this whole thing. Basically, you select, you hit Control C, you click here, and you Control V it, and you click move existing cells down, and there you have it. So one block represents one time period. So I ask first, is the simulation time, so this timer, is it lower than period 1 end? So basically, are we still within the first time period? That is 300. Then if that's true, I ask if there is any interstage that is active. If it is true, then that's fine. I don't do anything. I just go all the way to the end. Then I start it again. Ask if I am in the second period. So if you see simulation time bigger than or greater than period 1 end, and smaller than period 2 end. Very important when you use and or operators that you use brackets, otherwise you will get an error. So, and also here, when you have multiple lines in a little box, you need to use a semicolon, and you can go into a new line. You can start a new line by holding down Control and hit Enter. Then, if no interstage is active, that means we are in a stage. Then I check if stage 1 is active, or stage 2, or stage 3. If stage 1, I check if stage 1 duration is smaller than period 1 stage 1 time. So I have period 1 stage 1 time, that is a constant here, that's 10. That means period 1 stage time 1, basically stage 1 time in period 1. So here, this way you can use a different green time in each period. So in period 1, I want my stage 1 time to be 10 plus 6 seconds, as we discussed before. If that is true, I don't do anything because my stage duration is still within that. But once that is not true, so if it is equal or greater, it will go and initiate into stage 1 to 2. So I will go to the next stage. Then I'm here. Go now. This won't be true. This won't be true. I go back again. This won't be true. I'm back here. This is true. I'm um, I'm in an interstage. So the model keeps running basically until my interstage is over. When it's over, I'm going to be in stage 2, but still in the first period. In stage 2, what I check is the stage duration of the second stage is smaller than the period 1 stage 2 time. That. So that means if it has run 15 minutes, for 15 minutes, sorry, seconds, and if I reach that, that will represent a 21-second full total green time by including this 6 seconds, so 12 minus 6. And then I go to the next stage, and it will keep going on like this until my simulation timer reaches the end of period 1. And once that's true, then I will go to the next one, and here the stage duration will be checked against the period 2 stage 1 time, period 2 stage 2 time, and period 2 stage 3 time here. And in Vissim, basically, this means that in every 300 seconds this way, I will have a different fixed control. If you have a different period lengths, let's say an hour, your period 1 will be 3.6 thousand. Then this will be 7.2 thousand. And this will be 9.8 thousand. And in those you will have your green times here for each. If you want to add more periods, you just copy paste this and paste it here. And you will add a new period 4 and here, a new period 3 stage 1, period 4 stage 1, period 4 stage 2 time, and period 4 stage 3 time. And if you have more stages, you just keep basically copy pasting this or inserting more lines here, like stage 4 active, stage 4 duration, period 3 stage 4 time, and then interstage will be not 3 to 1 but 3 to 4, and then you will have one back to 4 to 1. And if you run the model, so you can see we are in 200, so the model has relatively short. Okay, I was running it too fast, so we are in 100. Okay, let me make it slower a bit because it's crazy fast. The factor of 20. So now we have relatively short green times. Now if I go to 200, I'm there now, so you can see that the green times are longer. like I think 60 seconds what I gave, and then sorry, it was for 300, not from 200. It was a mistake. So it was 300, and then between 300 and 600 I have these very long ones, and then after 600 I will have short ones again. Yeah. So this is the way you do it. Just make sure that you set up your PUA file and VISVAP file, and you include in these times, or you exclude in these times, that 6 seconds, or if you have less or more, that minimum green time. So when you calculate these times here, just make sure that you include them in your timings. Thanks for watching. If you want to support my channel, please have a look at my Patreon page, where you can pledge your support by a few dollars. Or if not, then maybe just a like and subscribe would also help my channel to grow, and comment also to increase the appearance of my videos. Thank you very much, and see you next time.